Okay, in this problem we're trying to determine the probability of guessing the correct 4-digit garage code in 10 random guesses. So let's leave the 10 guesses off for a bit. Let's just see what's the probability of guessing right if you have one guess. If we can figure that out, then if you have 10 attempts, you can multiply that by 10. So what is the probability of a correct guess? So what counting process are we using here? It's a 4-digit code, which means you have to type the 4 digits in the correct order, so order matters, and repeats are not allowed. So, order matters, no repeats. This is a permutation. So, the number of possible garage codes, we'll use permutations to count that. So let's see, what is the probability of, let's say, a correct guess? Well, if you're guessing 4 digits, how many correct guesses are there? Well, you have to get all 4 digits correct in the right order, so there's only one way to guess right. And so definition of probability, the number of ways the event could happen, which is 1, divided by the total number of possible outcomes of the procedure. The procedure is picking 4 digits out of, picking a 4-digit number, so 4 single digits out of 10 possible digits, 0 through 9. So 10 permutation 4. And let's go over here to Excel. 10 permutation 4. 5,040 possible 4-digit codes. So the probability of guessing right should be 1 out of 5,040. We'll leave it at that. Express your answer as a fraction. Okay. Now, part B, same question, except, oh, you know what? Let's go back and say, okay, this is the probability of guessing right if you have one guess. And now let's say, okay, well, there's 10 guesses. So let's multiply that by 10. So probability of guessing right in 10 guesses should be 10 over 5,040, or that reduces to 1 over 504. Now I'm ready to actually circle that in green. So now for part B, what's the probability of guessing correct, again with 10 guesses? The difference here is repeated digits are allowed. Well, we can't use permutations anymore because permutations and combinations both are only in situations where repeats are not allowed. So here, probability of a correct guess. Well, again, there's only one correct guess. And how many possible guesses are there? Well, you have 4 digits, so think about this as a 4-step process. So we'll use the fundamental counting principle here. You have 10 options for the first digit, 10 options for the second, 10 options for the third, and 10 options for the fourth. So 10 times 10 times 10 times 10, or 10,000. Then, not red. Then we have, again, 10 random guesses, not 1, so we'll multiply by 10. This gives us 10 over 10,000, or 1 over 1,000. Okay, so we have the probability of guessing right with repeats and without repeats. So part C, if you don't have any repeated numbers, how much easier is it for someone to guess the code? Well, if you compare these two answers from part A and part B, part A is about half, not exactly half, but just about half of part B. Or, I'm sorry, twice as much as part B. So part B is half as much as part A. So how much easier is it to guess if you know there's no repeated numbers? Let's say approximately or about twice as easy. And that's because 1 over 504 is about 2 times 1 over 1,000, which would be 1 over 500. Okay, so let's do that. And so let's go back to no repeats. What's the probability of guessing correct with a 6-digit code? Okay, so we'll do the same thing we did in part B, except we'll say probability of a correct guess. There's 1 right answer, and how many possible 6-digit codes are there? That should be 10 permutation 6. Okay, let's go back to Excel. What is 10 permutation 6? $151,200. So probability of guessing right here. 151,200. So what the question here is, what does that say about security? You are much, much, much more secure with a 6-digit code than you are with a 4-digit code. Okay, and that does it for this problem.